Why are Linux kernel tracebacks important? Have you ever wondered what happens behind the scenes when your Linux system crashes? Understanding Linux kernel tracebacks can provide some clarity. These tracebacks are vital because they capture the sequence of function calls that led to a kernel crash or error. This includes situations like a kernel panic or an unexpected failure. When a problem occurs, the kernel traceback acts like a roadmap, showing the path the kernel took before hitting a snag. Without this information, figuring out what went wrong would be quite challenging. The Linux kernel is a core part of Linux distributions, managing everything from hardware to system resources. Since it operates at a low level, any bugs can lead to system instability or crashes. So, how do tracebacks help? They allow developers and system administrators to identify where in the kernel code the issue happened. This is especially important because traditional debugging methods often do not work well with the kernel's complexity. The traceback shows the call stack at the moment of failure, making it easier to pinpoint the problem. Kernel tracebacks are often accompanied by debug symbols. These symbols link function addresses to specific lines of code, making it simpler to interpret the traceback. Without these symbols, you might see function names and offsets, but you wouldn't be able to connect them to the actual source code, which limits their usefulness. In addition to tracebacks, Linux provides various tracing tools that monitor kernel activity in real time. For instance, tracepoints are predefined hooks in the kernel code that log specific events. Kprobes allow for dynamic insertion of probes at almost any kernel address, collecting valuable data. These tools help provide context around tracebacks by showing what the kernel was doing before a problem arose. From a broader perspective, Linux kernel tracebacks highlight the operating system's focus on transparency and developer tools. Unlike some other operating systems, where kernel debugging can be restricted, Linux offers extensive tracing and debugging interfaces. This is particularly beneficial for developers working on Linux distributions or custom kernels, as well as for system administrators managing Linux servers or embedded systems. In practical terms, kernel tracebacks enable faster identification of bugs and their root causes. They provide a better understanding of how the kernel executes code. This leads to the development of more stable and reliable Linux kernels. They also enhance troubleshooting for system crashes and hardware issues. Overall, Linux kernel tracebacks are a fundamental tool for maintaining the health and stability of Linux systems. They support both kernel development and operational troubleshooting, making them essential for anyone working with Linux.